Welcome everyone. Question number 201. Circular slab is used for option A, roof of pump houses constructed above the tube wells, right. Option B, roof of a traffic control post at the intersection of the roads, right. Option C, floor of circular water tanks, right. Option D is the right answer, all of these. Question number 202. When a circular slab simply supported at the edge is loaded with uniformly distributed load, the terraces are developed in both radial and circumferential direction. Option C is the right answer. Question number 203. If W is the uniformly distributed load on a circular slab of radius R is freely supported at the edges, then radial moment at the middle of the slab will be 3WR square by 16. Option B is the right answer. Question number 204. If W is the uniformly distributed load on a circular slab of radius R is freely supported at the edges, then radial moment at the edges of the slab will be 0. Option A is the right answer. Question number 205. For a circular slab carrying a uniformly distributed load, the ratio of maximum negative radial moment and the maximum positive radial moment is equal to 2. Option A is the right answer. Question number 206. In a circular slab, the reinforcement is provided at the convex side of the slab. Option A is right answer. Question number 207. When a circular slab simply supported at the edge is loaded with uniformly distributed load, it bends in the form of a saucer. Option A is right answer. Correct. Question number 208. A ribbed slab is provided where? Option A, plain ceiling is required, right. Option B, thermal insulation is required, right. Option C, acoustic insulation is required, right. Option D is right answer, all of these. Question number 209. The thickness of the topping of a ribbed slab is kept from 50 to 80 mm. Option C is right answer. Question number 210. In a ribbed slab, the clear spacing between the ribs should not be more than 450 mm. Option B is right answer. Question number 211. For a ribbed slab, the overall depth of the slab shall not exceed 4 times the width of the slab. Option C is right answer. Question number 212. The width of the rib for a ribbed slab should not be less than 75 mm. Option A is right answer. Question number 213. The diameter of a bar used in the ribbed slab should not be more than 22 mm. Option C is right answer. Question number 214. The footing is that portion of a foundation which do not deliver the load to the soil. No. Option B is right answer. False. Question number 215. According to Tarjagi, a foundation is said to be shallow if its depth is equal to its width. Option A, equal to its width. Option B, less than its width. Option A and B. That means option C is right answer, either A or B. Question number 216. The object of providing foundation onto a structure is to, option A, distribute the load of the superstructure over a larger bearing area, right. Option B, prevent lateral movement of the supporting material, right. Option C, increase the stability of the structure, right. Option D is the right answer, all of the above. Question number 217. A footing which supports 2 or more columns is termed as combined footing. Option A is right answer. Question number 218. Which of the following statement is correct? Option A, the strap footing does not transfer any pressure to the soil, right. Option B, a raft footing is a combined footing that covers the entire area beneath a structure, right. Option C, a pile foundation is used where the topsoil is relatively weak, right. Option D is the right answer, all of the above. Question number 219. In a footing, it is used to assume that the maximum value of transverse bending will occur at a distance equal to measured from face of the column. Effective depth. Option B is right answer. Question number 220. When the footing is symmetrically loaded, the pressure beneath the footing will not be uniform. Option B is right answer. Question number 221. For the purpose of design of reinforced concrete footings, the pressure distribution is assumed to be linear. Option B is right answer. Question number 222. According to IS 456/1978, the thickness at the edge in reinforced concrete footings shall not be less than 150 mm for footing on soils. Option B is right answer. Question number 223. According to IS 456/1978, the thickness at the edge in reinforced concrete footings on the piles shall not be less than 300 mm above the top of the piles. Option A is right answer, correct. Question number 224. That weight of the footing is assumed as 10% of the weight of transferred to the column. Option B is right answer. Question number 225. The net upward pressure on footing P naught is given by, option B is right answer, W into Q naught divided by W plus W dash. W is the weight transferred from the column, W dash is the weight of the footing, Q naught is the shape bearing capacity of the soil. Question number 2 to 6. If the net upward pressure on a square footing is P naught, width of the footing is capital V, and width of the column or wall is small v, then maximum bending moment M near the column is given by option C is right answer. M equal to P naught into capital V by 8 into B into capital V minus small v square. Question number 2 to 7. For M15 concrete, the unit punching shear strength of concrete is taken as 1 Newton per millimeter square. Option A is right answer. Question number 2 to 8. The depth of a square footing should not be less than 150 mm. Option A is right answer. Question number 2 to 9. For a square footing of with capital V, depth of footing capital D considering punching shear is calculated by the relation. Option B is right answer. Capital D equal to P naught into capital V square minus small v square divided by 4 into small v into tau p, where P naught is the net upward pressure on footing, small v is the width of the column, and tau p is the unit punching shear strength of the concrete. Question number 230. When there are some restrictions on the maximum value of the footing, a rectangular footing should be provided even for square column. Option C is right answer. Question number 231. The footing at the base of a circular column may be square or circle. Option B and C. Option D is the right answer. Both B and either B or C. Question number 232. The depth of circular footing capital D for punching shear consideration is given by. Option A is right answer. Capital D equal to P naught into root over capital R square minus small r square divided by 2r into tau p, where capital R is the radius of the circular footing, small r is the radius of the column, P naught is the net upward pressure intensity of the footing, and tau p is the unit punching shear strength of concrete. Question number 233. A combined footing is provided when the option A bearing capacity of the soil is less, right. Option B, n column is near a property line, right. Option C, columns are very near to each other so that their footing overlap, right. Option D is the right answer, all of the above. Question number 234. A combined footing may be. Option D is the right answer, either A or B. Question number 235. In order to get uniform pressure distribution under the combined footing, the center of gravity of the footing area should not coincide the center of gravity of the combined loads of the two columns. No. Option B is right answer. Question number 236. The length of a combined footing for two columns is capital L, and the center to center distance between the column is small l, and the distance of center of gravity of the column loads from the center of the left hand column is x bar. In order to have uniformly distributed load on the footing, the projection small a2 on the right hand side of the column is. Option B is right answer. A2 equal to capital L by 2 minus within bracket small l minus x bar. Number 237. The combined footing in the longitudinal direction will have. Option A, sagging bending moment in the two cantilever portions, right. Option B, hogging bending moment in the some length of middle portions, right. Option D is the right answer, both A and B. Question number 238. The combined footing in the transverse direction will have sagging bending moment. Option A is right answer. Question number 239. The footing have a tendency to bend in the form of a saucer near the columns. Option A is right answer. Agree. Question number 240. In a combined footing, the section near and around the column will be subjected to maximum bending stresses. Option B is right answer. Question number 241. At a certain section in a combined footing for two columns carrying unequal loads, the shear force is 0. At this section, hogging moment is maximum. Option D is right answer. Question number 242. A combined footing for two columns would be designed for the maximum hogging bending moment. Option B, sagging bending moment at the outer face of the each column.
Both option A and B are right.
Question number 243. In a combined footing, the reinforcement should be placed. Option A, on the bottom face of the sagging bending moment. Option B, on top face of hogging bending moment.
Option A and B both are right.
Question number 244. A combined trapezoidal footing for two columns becomes essential when. Option A, there is some restriction on the total length of the footing, right. Option B, a heavily loaded column is near the poverty line, right.
So both options are right.
Question number 245. When the shear stress in a combined footing does not exceed 0.5 Newton per millimeter square, then 8 leg shear should be provided. Option A is right answer, true. Question number 246. The end bearing piles are used. Option A, to transfer load through water or soft soil to suitable bearing stratum. Option A is right answer. Question number 247. The precast concrete piles are generally used for maximum design load of about 80 tons except for large pre-stressed piles. Option C is right answer. Question number 248. The hammer used in the driving pile should be. Option A, drop hammer. Option B, diesel hammer. Option C, vibratory hammer. Option D is right answer, all of these. Question number 249. That in designing reinforced concrete piles as a column, it is considered as fixed at one end and hinge at the other end. Option C is right answer. Question number 250. The length of a reinforced concrete pile is taken as two-thirds the length of embedded in the firm stratum. Option C is right answer. Question number 251. For reinforced piles having length up to 30 times its width, the main longitudinal reinforcement should not be less than 1.25% of the gross cross-sectional area of the pile. Option A is right answer. Question number 252. Which of the following statement is wrong? Option A. The volume of lateral reinforcement provided in the reinforcement pile should not be less than 0.2% of the gross volume of the pile. Right. Option B. The center to center spacing of lateral reinforcement in reinforced pile should not exceed half the width of the pile. Right. Option C. When the pile has to penetrate hard stratum, the lateral reinforcement at the top of the pile for a distance of 3 times width should be in the form of helix. Right. So option D is the right answer, none of the above. Question number 253. When a pile of length L carrying uniformly distributed load W per unit length is suspended at one point, then maximum bending moment at point of suspension will be WL square by 8. Option C is right answer. Question number 254. When a pile of length L carrying uniformly distributed load W per unit length is suspended at 2 points, then maximum bending moment at points of suspension will be WL square by 47. Option B is right answer. Question number 255. If the maximum bending moment of a pile of length L carrying uniformly distributed load W per unit length is WL square by 90, then pile is suspended at 3 points. Option C is right answer. Question number 256. A pile of length L carrying uniformly distributed load is suspended at 2 points. The hogging bending moment at the point of suspension will be equal to sagging bending moment at the middle of the pile if the point of suspension from the either end of the pile is equal to 0.207 L. Option B is right answer. Question number 257. A pile of length L carrying uniformly distributed load is suspended at 3 points. The bending moment will be least if the end points are located at a distance of 0.15 L from the corresponding ends. Option A is right answer, correct. Question number 258. According to Rankin's theory as applied to retaining walls, option A, soil mass is semi-infinite, homogeneous, dry and cohesionless. Right. Option B, back of the retaining wall is vertical and smooth. Right. Option C, retaining wall yields about the base. Right. Option D is right answer, all of the above. Question number 259. According to Rankin's theory, the intensity of active earth pressure Pa trying to move the retaining wall of height h away from the backfill is given by. Option C is right answer. Pa equal to W into H into 1 minus sin phi by 1 plus sin phi, where W is the unit weight of the soil, phi is the angle of internal friction for the backfill. Question number 260. The total active earth pressure Pa or resultant pressure per unit length of the retaining wall is given by. Option C is right answer. Pa equal to W H square by 2 into 1 minus sin phi by 1 plus sin phi. Question number 261. Total active earth pressure acts at h by 3 above the base of the retaining wall. Option B is the right answer. Question number 262. In submerged backfill, sand field behind the retaining wall is saturated with water. Option B is right answer. Question number 263. If the surcharge is horizontal and carries a surcharge of intensity W1 per unit area, then pressure intensity Pa at the base of the retaining wall of height h is given by. Option A is right answer. Pa equal to W into H into 1 minus sin phi by 1 plus sin phi plus W1 into 1 minus sin phi divided by 1 plus sin phi. Question number 264. The overturning moment due to active earth pressure at two of the retaining wall is. Option C is right answer. WH cube by 6 into 1 minus sin phi by 1 plus sin phi. Question number 265. When the retaining wall has a sloping backfill with surcharge angle beta, then intensity of lateral earth pressure Pa at the base of the retaining wall of height h is given by. Option B is right answer. Pa equal to WH into cos beta minus root over of cos square beta minus cos square alpha. cos square phi divided by cos beta plus root over of cos square beta minus cos square phi. Question number 266. In the above question, the total active earth pressure will act at h/3 from the base of the retaining wall in a direction perpendicular to the surcharge. No. Option B is right answer. Wrong. Question number 267. The passive earth pressure is exerted on the retaining wall when it has a tendency to move towards the backfill. Option B is right answer. Question number 268. A buttress in a wall is intended to provide lateral support to the wall. Option B is right answer. Question number 269. In the design of a masonry retaining wall, the resultant load should fall within a distance of 1/6 of base width on either side of the midpoint. Option C is right answer. Of its midpoint. Option C is right answer. Question number 270. In a reinforced concrete retaining wall, a shear key is provided if the retaining wall is not safe against sliding. Option C is right answer. Question number 271. The factor of safety due to overturning of the retaining wall is generally taken as 2. Option A is right answer. Question number 272. The factor of safety due to sliding of retaining wall is generally taken as 1.5. Option B is right answer. Question number 273. A reinforced concrete T-shaped cantilever retaining wall is shown in the figure 14.14. The portion AB is known as stem.
Option C is right answer.
274. In the figure 14.14, the toe slab is portion D. Option D. Option D is the right answer. Question number 275. The toe slab of a retaining wall is reinforced at the bottom face of the slab. Option A is right answer. Yes. Question number 276. The stem of a retaining wall is reinforced near the each side. Option A is right answer. True. Question number 277. The heel slab of a retaining wall is reinforced at the top face of the slab. Option B is right answer. Question number 278. In a cantilever retaining wall, the bending moment in the vertical stem varies as h cube. Option C is right answer, where small h is the height of the stem. Question number 279. In a cantilever retaining wall should not be used for heights more than 6 meters. Option B is right answer. Question number 280. The counter force in a retaining wall supports the heel slab. Option C is right answer. Question number 281. The spacing of the counter force usually varies from 1/3 to 1/2 of the height of the wall. Option C is right answer. Question number 282. The length of the staircase situated between two landings is called flight. Option B is right answer. Question number 283. The sum of tread plus twice the rise of a stair is kept as 600 mm. Option D is right answer. Question number 284. The product of tread and rise in mm of a stair is kept as 40,000. Option B is right answer. Question number 285. In a residential building, the rise of a stair may vary between 150 mm to 200 mm. Option B is right answer. Question number 286. The tread of a stair is kept 250 mm to 300 mm for public buildings. Option A is right answer. Agree. Question number 287. When the stair slab is spanning horizontally, a waist slab of about 80 mm is provided. Option B is right answer. Question number 288. The dead weight of the stair consists of dead weight of the waist slab. Option A is right answer. Question number 289. If capital R is the rise and capital T is the tread of a stair spanning horizontally, the each step is designed by considering it equivalent to a horizontal beam of width root over of r square plus t square measured parallel to the slope of the stair. Option A is right answer. Correct. Question number 190. In stairs spanning horizontally, the distribution reinforcement provided in the form of 6 mm diameter rods and 30 cm center to center is normally adequate. Option B is right answer. Question number 291. If capital R is the rise, capital T is the tread, and capital W is the weight of the waist slab on the slope, then equivalent weight on the horizontal plane will be equal to. Option C is right answer. W, capital W into root over of R square, capital R square plus capital T square divided by capital T. Question number 292. The pre-stressed concrete induces artificially compressive stress in a structure before it is loaded. Option B is right answer. Question number 293. A pre-stressed concrete member is made of reinforced concrete. Wrong. Question number 294. In a pre-stressed concrete structure, option A, dead load of the structure is reduced. Right. Option B, cracking of the concrete is avoided. Right. Option C, cost of the supporting structure and foundation is reduced. Right. Option D is the right answer. All of the above. Question number 295. In a pre-stressed concrete member, option D is the right answer. High strength concrete and high tensile steel should be used. Question number 296. In pre-stressed concrete structures, no tensile stresses are induced. Option A is the right answer. Correct. Question number 297. The ultimate moment resisting capacity of a simply supported pre-stressed concrete beam is obtained by using.
Option B is right answer. Stress strain relationship of concrete and steel.
Question number 298. The ultimate strength of the steel used for pre-stressing is nearly.
Option D is right answer. 1500 Newton per millimeter square.
Question number 299. The cube strength of the concrete used for pre-stressed members would not be less than 35 Newton per millimeter square. Option C is right answer. Question number 300. The assumption made in the design of pre-stressed concrete section under working load is that option A plane cross section before loading remain plane after loading, right? Option B, any change in the loading produces change of stress in concrete, right? Option C, pre-stressing in steel remains constant, right? Option D is right answer, all of the above. Question number 301. The cable for a pre-stressed concrete simply supported beam subjected to uniformly distributed load over the entire span should ideally be. Option D is the right answer, parabolic with zero eccentricity at the ends and maximum eccentricity at the center of the span. Option D is the right answer. Question number 302. In the post-tension pre-stressed concrete beam, the end block zone is the zone where between the end of the beam and the section where only longitudinal stresses exist. Option B is the right answer. Question number 303. The propagation of a shear crack in a pre-stressed concrete member depends upon shape of the cross section of the beam. Option D is the right answer. Question number 304. The major loss of pre-stress is caused due to option A, creep of concrete. Option B, relaxation of steel. Option C, shrinkage of concrete. Option D is the right answer, all of these. Question number 305. The loss of stress with time at a constant strain is called relaxation. Option A is right answer. Question number 306. The loss of pre-stress in pre-tensioning system are due to the shrinkage and creep of concrete. Option B is the right answer. Question number 307. If the loading on a simply supported pre-stressed concrete beam is uniformly distributed, the centroid of the tendon would be preferably a parabolic profile with convexity downward. Option C is right answer. Question number 308. In pre-tensioning scheme, pre-stress load is transferred in
Either single stage or multi-stage process depending upon the magnitude of load transfer. Option C is the right answer.
Question number 309. In a conventional pre-stressing, diagonal tension in concrete decreases. Option B is right answer. Question number 310. The magnitude of loss of pre-stress due to relaxation of steel should be taken to vary from 2 to 8% of the average initial stress. Option B is right answer. Question number 311. According to Indian standard, the total amount of shrinkage for a pre-tension beam is taken as 3 into 10 to the minus 4. Option A is right answer. Question number 312. At the time of tensioning, the maximum tensile stress beyond the anchorages should not exceed
80% of the ultimate strength of the bar for steel without a definite yield point, right? And option D, the yield stress for steel with guaranteed yield point. So both options C and D are right.
number 313. For pre-stressed structural element, high strength concrete is used primarily because high modulus of elasticity and low creep. Option D is right answer. Question number 314. When tendons of a rectangular pre-stressed beam of cross-sectional area A is subjected to a load W through centroidal longitudinal axis of the beam, then maximum stress in the beam section will be. Option A is right answer, W by A plus M by Z, where M is the maximum bending moment and Z is the section modulus. Question number 315. In the previous question, minimum stress in the beam section will be. Option B is the right answer, W by A minus M by Z. Question number 316. The diagonal tension in pre-stressed concrete member will be less than the shear stress. Option B is right answer. Question number 317. When a pre-stressed rectangular beam is loaded with uniformly distributed load, the tendons provided should be parabolic with convexity downward. Option A is right answer, true. Question number 318. In Lee Mackel system, low alloy steel bars are used as pre-straining tendons. Option B is the right answer. Disagree.
Suppose this is the simply supported beam of span L. So we know the bending moment due to load will be WL by 4, and the moment due to the pre-stress force will be force into distance P into E. And by equilibrium we can equate equation 1 equal to equation 2. So E will be equal to WL by 4P.
Option D is right answer, WL by 4P, where P is the tension in the bent tendon. Question number 320. A simply supported concrete beam pre-stressed with a force of 2500 kN is designed by load balancing concept for an effective span of 10 meter and to carry a total load of 40 kN per meter. The central depth of the cable profile should be.
The bending moment due to load will be W square by 8 and the bending moment due to pre-stress force will be P into E. Now if we equate these two bending moment, we will get the central dip is equal to 200 mm.
Option B is the right answer, 200 mm.